Yeah. Quick review. So these are, I picked out the problems that were based on people's performance on the review assignments. These are the ones that were the toughest. This one, yeah, I kind of get why a little bit. I mean, there's a few things about this that are a little tricky, but it's easy to. I'll go through it again, and I bet you you'll have it down. So, what kind of function is this? Based on the shape, absolute value. Very good. It's a V shape, isn't it? It's upside down, but it's a V shape. So it's an absolute value function. So first things first, we got to remind ourselves, in order to be able to do these problems successfully, you got to remember what the vertex form is. And if you know that, and you know what the parts of the vertex form mean, this is a slam dunk, piece of cake. So what's vertex form for an absolute value function? Y equals A absolute value
B x plus B minus B. H.
Good, I'm hearing it. Plus K. Okay, we good? Okay, we good? Back table, we good? Okay. Okay, so remind us real quick, what's the meaning of these things? What are H and K? What do they represent? X and Y, what? What do H and K mean? What? X and Y coordinates.
Coordinates.
Of what?
The high point.
Okay, the vertex, the point,
yes.
right? The vertex. So. Okay, good. And what does A mean?
Slope.
Slope. Okay, of what?
The right.
The right side of the V. Okay, good. Okay, so let's do the vertex first. So I just have to identify the coordinates of the vertex. Now, what are those? There's my vertex. What are those coordinates? 4, -2. Good. Over 4, down 2. So H is 4, K is -2. Okay, now for A, remember this is the part that I think people, if there's a part they miss on this, especially if it's one that's opening down, people tend to use the left 2 points for the slope. I guess because they're more convenient or something, I don't know. But that's not what we do. We want to just visually or mentally kind of block out the left side and just focus on the right side, because it's the slope of the right side that matters. So looking at those 2 points, now quickly review in your mind here, slope is what divided by what?
MX.
Rise over run, good. So it's going to do the Y part first, right? But if you imagine an ant crawling from that point to that point, he's going to do the trip in a horizontal and a vertical path. He always starts going vertically and then ends going horizontally, right? Rise means vertical, run means horizontal, okay? So if our ant does that, does he go from left to right or right to left also? Left to right. It's like you're reading a book. You always are going to read across the function from left to right when you're calculating a slope. So this ant is going to start there. He's going to go down. Whoops. He's going to go down. He's going to go down 1 and over 1. So what's our slope of the right side?
-1.
-1. Yeah. A is just -1 over 1, which is -1.
A lot of negatives.
Right? A lot of negatives. Okay. So if I know that stuff, if I know that A is -1 and HK is 4, -2, all I have to do is plug that stuff in and I'm done. That's it. Right? So Y equals, A is -1 we said, right?
Yeah.
So negative, do I write the 1? I don't. I just put a negative sign there and you know that. Because what would this be? What's the slope of this line? -1. Because that's how we write a coefficient of -1, just a negative sign. You already know that. So negative absolute value of x minus 4. Right?
Plus
Remember that? That's the weird one. You subtract the amount that it slid to the right. Okay? And then
-2
plus -2, which we'd write as just -2. That's our answer. Questions?
No.
Good? Okay. Okay. Good luck. So what about this one? There's another one. Now, these are, I can see where there's a couple things that are tricky about this, but what you gotta remember is these are all the same. When you're doing problems like this, where you're trying to write the equation of a line in slope-intercept form, you always start with the slope and calculate a y-intercept. The slope isn't given to you directly here, but we can calculate it. So, how do I calculate a slope? Okay, good. So, good. M equals y2 minus y1, not x2 minus x1. That goes on the bottom, right? y2 minus y1 over x2 minus x1. And here are my 2 points. So what does that work out to be? Okay, good. 10 minus negative 2 makes it a plus over 2 minus negative 8. So that gives me what? 12 over 10, which reduces to 6/5. Good. Okay, is that our slope? No, it's not, because if we read the problem carefully, it says that we're passing through the point 6, negative 4 perpendicular to the line through those 2 points, right? So the slope that we just calculated is not our slope. It's the slope of a line perpendicular to ours. How are perpendicular slopes related?
Just switch them in negativeness.
Opposite reciprocal. There we go. Opposite reciprocal. So our slope is not this. It's the opposite, so it's negative. This was positive, ours is negative, and we flip the fraction. 5, 6. There we go, we got our slope. All we got to do is calculate b. Now, how do we always calculate b? Y equals mx plus b. And I'm just going to substitute for everything except b so I can solve for b, right? So m is negative 5, 6. What's y? Negative 4. I got to use this point, don't I? Because this is the point that my line passes through. So negative 4 is y. M is negative 5, 6. X is
6.
6, right? So I'm going to write that as 6 over 1 because I'm multiplying fractions. It's easier to see if we multiply fraction by fraction. Plus b, and all we have to do is just simplify and solve for b. So how do I multiply fractions? Straight across. Negative 5 times 6 is negative 30 divided by 6. Okay, negative 30 over 6 is negative 5, right? So negative 4 equals negative 5 plus b. Last step to get b by itself? Add 5.
Add b.
No. Add 5. So if I add 5, negative 4 plus 5 is? We got it. So there are 2 ingredients. I have a slope. I have a y-intercept. It only takes 2 ingredients to cook the line. That's it. So what's my answer? Y equals?
X plus 1.
Okay, good. Last piece of advice I'll give you on this one. Use the fraction template. Okay, if you're writing a formula out that involves a slope, don't do this. And this is, you're gonna have problems in Moodle. You're gonna have problems on calculators. You're gonna have problems everywhere if you do this. You gotta get out of this habit. Don't write this as not good. That's really ambiguous. It's not very clear what's being stated there. Is it negative 5 divided by 6, or is it negative 5 divided by 6x, or you know what I mean? Not good. So at the very least, you need to put that fraction in parentheses because it's being multiplied by something. But better than that, just make it look just like that. Use the template. Then you know you're doing that. Okay? Make sense? Okay? Good. All right, what about this? Okay, real simple. This is a super easy one to fix. And somehow I didn't do a good job explaining this because a lot of people were unclear about what that A means. Okay, so think of it this way. If I multiply a function by a number, so it's a function multiplier. Here's a good example that will help you remember this for always. Now imagine, visualize. I have got, and actually, you know what? Brain research says it really does so. If you can actually visualize this, you actually will always remember this. If you can visualize something, if you want to learn somebody's name, if you can visualize something about them, imagine them doing something funny, you can remember their name and never forget it. So if you do that, visualization works. Your brain will link these things more strongly. So visualize me holding a jar of cash up here, the jar of cash. I'm going to ask you a question here about this jar of cash. I'm going to give you three choices. I'm going to give you the amount of one of these three things. The jar of cash times, don't waste my Post-its.
Those are mine.
Oh, they are?
Yeah.
Oh, well, okay. Just make sure you pick them up. I've got this jar of cash. I'm going to give you the value of this jar of cash times 0.5, or 1.0 times the jar of cash, or 1.5 times the jar of cash. Which one do you want? 1.5, obviously, right?
Not greedy, no.
Oh, okay. So we want 1.5 because what does it do? Just by, you know this already. You have good number sense. What does it mean if I multiply a quantity, an amount, by a number bigger than 1?
It gets bigger.
It's getting bigger, right? If I want twice as much, it means I'm multiplying something by 2, right? If I want 3 times as much, it literally means 3 times whatever that amount was, right? If I multiply something by a fraction or a decimal that's less than 1, say a positive decimal that's less than 1, so between 0 and 1, what does that do? Makes it smaller, right? If I only want half as much of something, well, I would just multiply it by half, and that gives me half as much, right? 50% really means what? It means 0.5 times. Make sense? Okay, so if I multiply something by a fraction or a decimal whose absolute value is less than 1, it's going to give me a smaller amount. Same for functions. Same deal. I would stretch a function to make it bigger. I would squash a function, right? Shrink it to make it smaller. So what kind of number would I multiply by a function to make it bigger?
Something bigger than 1.
A number whose absolute value is bigger than 1. That's like getting more cash. If I want to squash a function, if I shrink it, I'm making it smaller, so I multiply by a number whose absolute value is less than 1. Okay, now what's the only thing that the negative sign does? Separate issue. Yeah, that just reflects it or not. If you multiply by a negative, it reflects it. If you multiply by a positive, it doesn't. But that's all the negative sign does. That has nothing to do with shrinking or stretching. That has only to do with the size of the number, the absolute value. The sign just tells you reflect it or not. So everybody think of one here. Think of an example of a number that would give you a stretched but not reflected function. When you got a number, raise your hand. Everybody think of one. Number that would stretch but not reflect. Okay. What do you think? What do you think, Trinity? 4. Yeah, that's a great number. That'll work. What's another one? 5. Any of those would work, right? What's a fraction that would work?
0.5.
2 over 1 would work. 5/4 would work. Any fraction where the top's bigger than the bottom would work, wouldn't it? Because that's bigger than 1, right? Okay, what's an example of a number that would shrink and reflect the function? Everybody buy that? Negative 0.5?
Yeah.
Negative reflects it, the 0.5 shrinks it. Right? Got it? Make sense? That's it. That's all there is to those. No big deal. Yes, sir. Okay, yeah, good question. What happens if it's actually equal to 1? What happens if it doesn't change the size at all? It stays the same size. So negative 1 would keep it the same size but reflected. Okay? All right, I'm going to skip. I don't know why people miss this one. It's just a slope. We already went through one like that, so I'll skip it. Here's one. Okay. Let's look at one of these. Okay, these I think I can see where people have a little bit of an issue with piecewise functions. They're kind of weird. But we'll just review it real quick. So first of all, when we're doing a problem like this, I'll have graph paper available. I'll make sure there's graph paper there. So I would sketch the thing out and then just make sure that they correspond. So in this case, where's the breaking point going to go? Where's our vertical line? 0. Already got it. Green line, right? So there's our breaking point. Which of those two pieces, the top or the bottom, goes on the left? Top one, right? Because of the inequality. And the easy way to remember that is when x is less than 0, less than means left of, right? Okay, right? And we know that on a number line, left stand means to the left of. So we're gonna be on the left side, all we have to do is over here, graph the line y equals negative 1/3 x plus 1. That's it. That's all we have to do. To graph a line, all we need are 2 points. And then I can just connect those points and I got it, right? There's a number of ways to get those 2 points. I could, if I wanted to, I could even use the y-intercept. And then a slope that takes me negative 1/3 is down 1 and over 3. Now that's on the wrong side. But if I just kind of go backwards from there, so if I reverse that, instead of going down 1 and over to the right, what if I went up and to the left? Does that make sense?
Yeah.
Those line up, don't they? So I could use those points to make my line if I wanted to. That's fine. I could also, if I wanted to, I could just make a t-table. And this is the way that I think we mostly talked about. Let's pick a good value of x that makes sense. So in this equation right here, what's a good value of x that's going to give us a nice integer answer, no fractions? Okay, like any multiple of 3 would work, wouldn't it? Because I'm multiplying by 1/3. Now, if I'm going to be on the left side, I got to pick a value, a negative value. So what's a good one?
-6.
Negative 6 would work. If I pick negative 6 and I plug that in, what's negative 1/3 times negative 6?
-3.
Yeah. Right? Oh, hold it. Negative 3?
+3.
No.
-3.
1/3.
I heard 2. How come? If I multiply straight across, negative times negative is positive. 1 times 6 is 6. So I get 6 over 3, which reduces to 2. Okay, so -6, +2, right?
Yeah.
We agree? So I go back 6, 1, 2, 3, 4, 5, 6, up 2. Is that right? 6. Well, I guess it is, isn't it? What happened? -6. Oh, plus 1. Right, I gotta add 1 to it. So I get negative 1/3 times -6 plus 1. That gives me 2 plus 1 is 3. Right? So I'm right there. -6, +3, right? Okay, so there's my point. And then I'll use a slope triangle and go down 1. I'll rise -1 and run +3. And there's my second point. And now all I have to do is just connect that line. I can do better than that. And extend, right? What kind of an endpoint does my left piece get if I have an equal sign there?
Filled in.
Everybody agree? Solid? It gets to keep the endpoint.
Yeah.
Okay, now the right side. Right side's a piece of cake. Right side we've got over here the function y equals +4/3 x plus 3. Well, being as we're, the y-intercept is, even though we don't get to keep it, it's going to be an open endpoint for our line, isn't it? Let's just start with that. So where is the y-intercept?
4.
3.
3.
So right there, I'll start with my open endpoint, and my slope will give me a second point. So what's that mean I do? Up 4, because it's positive, so I go up 4 over 3. There's my second point, connect and extend, got it, that's it, right? And really what you're going to be doing on the test is even easier. What you're going to be doing is just identifying a graph. And so you could just eliminate a lot of them through the process of elimination, right? You know, if I've got this function and I know that the left function has to have a slope of -1/3 and the right function has to have a slope of 4/3, I could even go through and say, aha, that passes, -1/3, +4/3. Whoops, doesn't pass. Cross that one off, and just narrow it down and then look more closely at the ones that are still candidates. Yes, sir.
There's a way to do that,
How's that?
because since the top one, which is to the left, has the equal sign
Yeah.
over it, and only one of those has the left side.
There you go. In this case, now I didn't include all the choices, but you could also use the idea, the fact that the top one keeps the endpoint, and so all these other ones don't do that. You could get rid of those immediately, couldn't you? So you could narrow it down pretty easily that way, right? Okay, this one, very simple. I know why people missed it, but it's an easy fix. I watched people doing this problem, a lot of the questions I got, people were trying to evaluate rather than solve. Now, evaluate is different. If it says evaluate p of x when x equals 4, that means I'm just plugging in 4 for x, but this is different. This is saying find x. Find is another code word in math for solve. It's asking you to find something, it's asking you to solve for it, right? So we know this means solve. So I'm going to have to solve an equation here. Find x when p of x equals negative 76. Well, remember what we said way back at the beginning of the year when we first started talking about function notation. We said that f of x is really just a fancy name for what? For y. Any function is. F is not any, there's nothing special about f of x. We could call it g of x or h of x or p of x or whatever. It doesn't make any difference. In this case, it happens to be p of x, but either one of those just means y, just a fancy name for y. Why would we use p instead of f? Who knows? Maybe the quantity that we're tracking is, I don't know, paycheck amount or something. It starts with a p. You know, no real reason. So all we're doing then is plugging in negative 76 for y, which is just written as p of x. That's it, right? So we're just solving the equation negative 76 equals negative 7x plus 8. What are the two steps I would use to solve for x there? First I would subtract 8 and then done. That's it. Okay? Okay, this one. These people have a harder time for some reason with these than the ones where if I give you an inequality, you have to pick the graph or even graph it. This seems harder for some reason. So this one we'll look at. So I know my answer is going to look something like this, don't I? I know it's going to be an inequality in slope-intercept form. So it's going to be y is something mx plus b. And that something is going to be some kind of an inequality, right? We've got 4 choices. So really, well, what about the mx plus b? What about that part? How do I get the mx plus b part? Where does that show up in the graph? Ah, okay, where'd you get that? Yeah, it's just the boundary line, isn't it? Right? The equation part of it, well, I should say the equation part, but the m and the b part come from the boundary line. All that the inequality does is just tell us which side of the boundary line to shade. And I guess also if it's solid or dashed, right? But mainly it tells us which side of the boundary line gets shaded. So from the graph, we can see very easily what m and b are. What's b?
8.
Yeah. B is 8. If I look at these 2 points right there, what's m? 1. Rise over run is 1 over 1, isn't it? So m is 1, right? So we got that part. That's no big deal. We know that we're going to get a y there and we're going to get a 1 there, so I just get x plus 8. But what's going to go there? Yeah, there's a shortcut, right? We know that if it's in slope-intercept form, shading below means less than, shading above means greater than, right? So we know right away, if we just remember that fact, that it's less than or equal to because it's including the boundary line, right? So we got to put the equals in there too, right? If I forgot that, I could just test a point. Test a point on the side that's being shaded. Maybe that's the easiest way to think about it, I guess. So in this case, I could just test the point 0, 0. If I put 0 in for x and 0 in for y, I just get 0 on this side and 8 on that side. Well, which way should it go? Is 0 less than or greater than 8? Yeah, it's less than. Or equal to because it's solid, right? Make sense? Okay? You tell me if any of these, I'm going to skip that one. I didn't actually even put one of these on the test, I'll tell you that. Just because of the format of the question, I didn't include it in the test. How do I know if the graph's a function? Vertical line test. Yeah, if a vertical line ever intersects more than one point or part of the function at the same time, then it fails and it's not a function. So this one is or is not. Looks like it is. None of the points line up vertically, do they? So that one would be. How do I evaluate a function? What am I doing there? Yeah, what am I doing with that 25? Plugging it in for x. So my answer is just a number. It's whatever 2 plus the square root of 25 is. What is that, by the way? So, okay, square root of 25 is 5, plus 2 is 7. 7's the answer. Yes. Okay. Okay, we did one like that. I think we're fine. That's easier than the one we did. Yep. Okay, that's fine. Okay, maybe this is last one. Last one. We're done. How do I evaluate a piecewise function here? Do I put the x into both pieces? No, can only go into one. How do I know which one? Leah, which one? Say it again.
If the number is bigger than the.
Oh, okay. I gotta look here, don't I?
Yeah.
Okay, so which one is true? Is one less than or equal to 1 or greater than 1? Yeah, top one. So we're gonna plug it into this guy, right? And really, there's the formula right there. So if I plug 1 in, I get 1/3 times 1 plus 2. So f of 1 equals, what's 1/3 times 1? So that's my answer. Here's the other dilemma. Write your answer as an exact real number. Can I say 2.33? No, not gonna work. That's not exact, that's rounded. So I've got to write this as an exact real number. How do I do that? Fractions. Yeah. Now, I'll tell you what, there is a way, and if you want to know this little trick, I don't have a problem showing this to you. Even on non-graphing calculators, there is a way that you can ask the calculator to give you back a fraction. And I'll show that to you. But you don't really need it here. If I want to add these two up, remember when I add fractions, I just get a common denominator? What's the smallest number that both 3 and 1 divide into?
3.
So I need to get a 3 on the bottom here. So I just multiply by 3 over 3, right? So I get 1/3 plus 6/3 is how many thirds? 7/3. Another way to do it. 1/3 plus 2 as a mixed number is just 2 and 1/3, right? How do I turn a mixed number into an improper fraction? Yeah, good. I take the number out front, multiply by the bottom, and add the top to get the numerator. So 2 times 3 is 6, plus 1 is 7 over 3. Okay? That's the way better? I kind of do too. When you can do it, it's convenient. Okay? All right. We don't have a ton of time, but let's head down to 205.